Thank you, everyone. For me, I'm honored actually that I'm called here to share my experiences with you, because I know what you're going through right now. I've been through that phase. It's a difficult one, but it means that in English they say it separates the good engineers from the experienced engineers. EPOKA is a good university, first of all. I think you made the right choice for it, because it really ticks all the boxes when it comes to civil engineering. We all know that the Albanian standard is what it is, but I think you guys have made the right choices to prepare for the market that is out there waiting for you. I want to do a bit of very short description of where I came from and how I got to where I am. I'm a civil engineer by background. I studied in London, in UK, since in 2000, and that was a long time ago. I think that I finished in 2007, and I started in 2003 civil engineering. Why I chose civil engineering? It's a very tough subject, but it really is. You gotta, especially nowadays, you gotta match what you want to do and what is out there. What is out there is a different world. You know, it's limitless opportunities. What you want to do, it gives you the key to one of these opportunities, and a bit of luck, you can get, you know, to good places and have a nice wage, have a good home, have a nice family and everything. But you got to be prepared what is out there. When I was to your face, I was very confused, to be honest. Really confused, because there is so many options. You read so much in the internet. Nothing is filtered. You got to do your own filtering. And by doing your own filtering is how good you make your choice to go to what you want. Hello. Before I did university, I actually, and I'm not shameful of that, I'm actually quite proud of that. I worked as a laborer, so I really did the shoveling and everything when I was in UK. This supported me through my university. During the university, and the work that I did was in railway maintenance. So my first choice after I graduated, it was railway engineering, which is okay. It's a bit boring, to be honest, because it's just a line, and you know, you gotta do the radius and what the velocity, blah blah blah, signaling and everything. Then I thought, you know, after railway engineering, I think I want to do something else. My other option was road engineering. I was one of the road engineer and tunnel engineer. I was one of the tunnel engineers and road engineers for the Bechtel-Lanenka motorway on the Durrës-Kukës, which was quite a very good and amazing experience. I learned a lot, because you see, when you go, I will explain this, I think, at the end of the presentation. But when you go to work, you should see yourself like a sponge. Like, you want to digest and get as much information as you can. This can help you achieve and move towards your career. You know, learn from the best, focus a bit, use your theoretical steps, what you learn from university, as well as the ground experience. Then after that, I completely took a different turn from my engineering career. I went to a conceptual design of a big project called the Zumax project, which is the international, the plans to make Vlora one of the international container ports. Nothing to do with my engineering, but it had the option to explore how can you use this engineering background that you have towards the management. Then I did that for a year. Then after that, I am where I am now. I'm the project engineer for Albania, covering the onshore and the offshore part, which is quite a big project. As I said, where you are now, it's a bit, it gets time to times it gets confusing, because you focus too much on the theoretical part. And my previous experience with EPOKA was that I taught legal aspect in construction. But I didn't do all of it legal aspect in construction, to be honest, because I know being in the real world and expecting the real CVs, you guys need to shape up your CVs in a good way and sell yourself to employers, which this is what is missing actually in Albania. Because everybody focuses on so much theory and so much construction, but there is that tiny bit which needs to sell you from college, university, to the real market. And I hope I can share that with you at the end of this presentation. Now I want to show you a bit of facts on the project. This is the overall, this is a gas project. It means that it doesn't mean that it does not need civil engineering. It's even better that it has civil engineering in it, because most of people, when they think of a gas project, they think of petroleum engineering, they think of mechanical engineering, which is, okay, I would say 40% of it is like that. But 60% is actually the route. You got major challenges on deciding where the pipe's going to go. You know, whether it's urban areas, non-urban areas, inclination, how much inclination, you name it. It's a gas project which starts from Azerbaijan. It goes through Turkey for more than 1,800 kilometers. Then it goes through Greece, which is about 547 kilometers. Then it goes to Albania, which is 211 kilometers. Then it goes on the sea for 114 kilometers towards Italy. And it has about 5 kilometers to join in the main network of gas, which supplies to the whole Europe. This presentation, actually, I took it because 2 weeks ago, we finalized the overall compound development permit, which is the first step of getting closer to construction the project. So it's a bit of data. I will get you bored on this first one. The second one is more interesting because it has more pictures, which is the offshore part. So as we discussed, as I said, Shah Deniz II, it goes to Azerbaijan. It runs through Azerbaijan, through Turkey, Greece and Italy. This is what we achieved so far on the project, which is the planning and the permitting. You should know that in civil engineering you don't learn these kind of things in permitting, especially because what is permitting is a little tiny bit which you have a construction permit, and it goes into it. It goes into this file by helping you know what is the legislation in the country, what can you do in the country, what is allowed and what is not allowed, and this is what the permitting does. So it's a bit of civil engineering mixed with lawyers. This is another potential route which you guys can take in the future, because you should know that this kind of things is a bit shortage in the current Albanian market and the Balkan markets. There is more focus into the civil engineering. The civil engineering shouldn't be only civil engineering. It should have a bit more 3D view of it, you know, like a bit of economics, a bit of law, which, you know, you'll see if you have this, you are a bit different from the normal market. This is again some permitting, environmental permit, which is quite important. Big companies, they take so much and spend so much money on environmental and health and safety, which again in civil engineering, where you are, it's not only in EPOKA, but I guess is all university. Even in my university in UK, they didn't mention so much environmental and health and safety, because they want you to be very rigid civil engineers, and they leave it up to you what you do with a civil engineer. So they give you the core of being a good civil engineer, but then how you mold it around to give it to the shape of the real market needs, a project manager, I don't know, a construction manager, it's up to you guys how you do it. So there's a bit of facts and figures about the project. It crosses 6 countries, more than 4,000 kilometers, more than 10 energy companies which are involved. So the reason why I brought this up is that this actual project is like a motorway for gas. It's not a motorway for cars, but it's motorway for gas, which means that we will do all the blocking of the valves and give a go-ahead where it stops, how we divert the gas. This is more likely like if you see it in an overview, this is a motorway of gas. These are again some little figures about the project. You see there is some mechanical engineering numbers there, I would say, which is the 48 inch, the 36 inch, and the bars. I mentioned earlier that this is not only a mechanical engineer, but is only a civil engineer. Where does civil comes into it? Civils come into the way the pipeline, for example, is going to be placed. By knowing how much bars and what risks it has on installation or production of pipes or gas flow into the pipe, civils help to determine the bed of the pipe, which is quite important, the characteristics of it. For example, we have selected 6 options to complete this pipeline. Out of 6, we have filtered 1 option. The reason why we did that is that we analyzed all civil impacts to the project, which a good example is geological conditions. You got to know where you put the pipes. If it's active faults, non-active faults, if it's got a history that it has landslides and all that kind of stuff. These are again some characteristics about the project, which is basically there is safety elements to the pipes. The safety element is, for example, if there is a change in weather, if there is for example, the temperatures that we make the project, the maximum, we have a temperature range for the weather conditions, which could be 44 degrees and up to -5 degrees. If we have a change in temperature which is more than 44 degrees, then we put in block valve stations, which are put every 20 kilometers. What they do is, as pressure changes because of temperature, because it's a gas, a gas can change its volume depending on temperature. Then what we do, these block valves, they will help stabilize the pressure within the valve. For example, if it's overheated, the pressure goes up, then we let some gas out of the 2 block valve stations. If it's in winter time and if it is a temperature of -5 and it goes below the -5, then what we do, we call in and we heat up gas so that it has the same volume throughout the traveling from A to B. This is the block valve station which I was explaining. In Albania we have 8 block valve stations. We have, knowing that you need to do a pipeline project, you know that one of the major characteristics of a pipeline is too many pipes. What do you do with them? You store them. So again, another concept of civil engineering is the logistics behind it. So if you're a good civil engineer and you got a road background, for example, you could help and shape up the logistics study, which is quite important because it has more than 10% of impact on the overall money which will be spent in the project, which is quite important. Campsites, it's another point where civil engineering comes into it. How does civil engineering relate to it? Well, again, it's the geological condition, it's the urban study. How many cars will go into that area which you will be selecting a campsite. How many people are in that village where you're going to put in a campsite? Are you affecting these people's lives? So again, it's that civil engineering which needs to have a bit more side views to the planning and preparation. These are when we start and when we finish, and this is typical construction site. basically it's very straightforward, but it gets complicated because of the risk factors of gas into it. So you got to make the civil engineering part perfect before you put in the pipe. And how do you do that? You select the base case, which is you select the corridor based on the all civil engineering and other aspects when you select the route. Then you prepare it and you make it nice and tidy just for the mechanical guys to come after you, put the pipe in, and then civils take over, to cover it up, make sure that all the risk factors are kept to where they should be. For example, I don't know, you don't put too much gravel when you backfill the pipe. So you put the pipe in and you don't put too much gravel because based on the calculation which I've made previously during the design phase. This is before and after. Again, this is the environmental part of it. Whenever there is big projects and there is more, we call them stakeholders, which are people that are representative of governmental bodies. I don't know, a directorate in agriculture, in the area, for example, in Korça, where the pipeline is going to go through. We need to make the project with as less impact as possible to the communities. That means that your engineering now needs to take another shape, which means that you don't only see it as diagrams. You got to know when you put the diagrams and the design to take these other factors into it, which is community. So in our case, for example, we'll have super duper engineering, but when we put the pipe in the ground, we take another turn. We use the civil engineering and we use the community liaison. Because we know that this pipe, for example, it's more than 25 years of project, and we want to have good community relation, because we have to do maintenance. God forbid, if there is an accident, we have to take the necessary measures and use the community, which are in our advantage, not into our disadvantage. Another challenge to this project is that, and I just want to tell you something, that this is quite new for me, the land easement and acquisition. But I learned on the project, because you always, as I said, you should see yourself like a sponge, by digesting and gathering more information from people, from experienced people. We have one challenge in this project, and is land easement acquisition. What does that mean? That means that when you design a project, another factor into it is that you need to have access to this land. And how do you do that? Well, you have to buy the land or rent it out. Unfortunately, in Albania it's the wrong example, because we have mishmash with our cadastral data, which means there's so many laws on registering your property, and you're lucky if you have your own certificate of property ownership. What we are doing is we are rebuilding the whole cadastre from scratch with our own money. And this is more than 12,000 people affected. That's a big number. And you got to talk to 12,000 people one by one, because you got to check whether they're the right owner or they're not the right owner. Why do we need that? Well, we need that because we need to construct our pipeline. If you don't have access to the land, that means that you cannot construct it. That means that you cannot have a construction permit. So again, these are things that you guys, for the time being, you don't know, because I would imagine this is at university phase. But as you progress into your career, don't be afraid of these things coming towards you, because this is what makes your learning career all the time. I mean, a civil engineer, an engineer in general, his learning curve does not finish. It's an ongoing learning curve. You have to learn, because this is what civil engineering is. And general engineering, this is what it is. Technology improves, new countries, new laws, new projects, new experiences. It's all a learning curve. It's up to you how good you are to observe this information and make it to your best advantage.
Yeah, so can I, short question, how, according to Albanian laws, how many meters are owned by the land owner if it is deeper than, in some countries it's specified in the law that everyone owns 6 meters deep, but below it, it belongs to the government. Is there such a law in Albania?
There is, but this is only for usage.
Okay.
For example, an oil exploration project. There is oil reserves in the earth, which I believe is below 2 meters.
Yeah.
From 0 to 2 meters is to the landowner. Below 2 meters is government owned. I'm not quite sure on the number, but this is
deeper than 3 meters.
Well,
Still need permission.
Yeah, what we buy, for example, in our project, we will go more than 220 meters. We will dig in more than 220 in onto the ground. So we do not have as a way of using the materials from the government, but we will buy for our own use because we will give it back to the owners anyway. We will reinstate the land. But there is a law, yes, there is a law on expropriation. This is the offshore part. Compressor stations. Compressor stations are another factor to the project, which again they manage the pressure on the gas, and these help the block valves, like I explained before, to have a constant pressure in the pipeline. You need a constant pressure because if you have an irregular pressure, it means that you will spend more money into maintenance. And the maintenance in a gas project are quite expensive because the pipes on its own are expensive, the welding on its own are expensive, the installation on its own is expensive. So you imagine you will have to do all this circle again if something goes wrong to the pipes. And normally the lifespan, when engineering goes into a lifespan of the project, normally this type of project will go after more than 25 years. The engineers who design these kind of projects, it's their duty to match the quality of the material selection, of the type of construction, of the natural causes such as rainfall, for example, and heat. All these elements go into the designing and give you a final product, which is a pipeline for 25 years plus. So this is what you'll be doing one day. You never know. Before we construct, there is a logistics part of it. The logistics part, especially in developing country, which Albania is, there's not many roads where we can take the pipelines. We are talking about pipelines of 18 meters long, which would need a typical truck of 22 meters. And they would turn into roads with radius of less than 5 meters. And this is a big challenge. What the company has decided and has taken into its calculation during the design phase is this is our cost, because this is our direct impact on how fast we can progress with the project and how fast we can construct the project. So what we are doing, we are designing roads, as you see, more than the phase 1 is more than 19 kilometers of roads, which we will upgrade and we will renew. What do? There is existing roads right now that are of a width of less than 3 meters, which means they are used by farmers with a little tractor going to the farmland and doing the farm day-to-day business. But these are not enough for us. We need more than 5 meter width. So it's our cost. We have to design them now based on the geological condition and other conditions, and make them good, fit for purpose for our project. So in total we have like 57 kilometers of new construction, 44 which are existing. So all we need to do is just make them good just for our logistic purpose. And on the way we have noticed that some of the bridges which we'll cross through are not enough to withhold our tonnage, which is a typical 22 truck is 40 tons. It's not the average truck that you see in Albanian roads on a normal day. Normally it's 22, 25, 30. So what we do is that we have extended this design scope, and we will add another 52 bridges into it. So we will rehabilitate these bridges by making them good for our purposes, and then once we finish, then we will give them as a gift to the government. On top of it, we will go through 655 kilometers of roads we will use. This is a basic estimation. So what we do is that these 655 kilometers that we will use, we have put them under the monitoring regime. So we will do an initial assessment of the roads based on the civil engineering point of view. We will go back to the road authority and tell them, look guys, this is the condition that we found them. If we damage them, then we will maintain them and put them good to the previous condition that they are. This is a typical road design that you should be encountering in your life after university. Again, this is the land access and acquisition, which is one of the challenges that we have for the project. And as you see the numbers, you have private, state and unidentified, which is quite a big number. People do not register their land because of simple reasons, or they don't want to pay taxes to the commune. So they just leave it there. Now, if there is a project like this going close to their land, now they're just shaking. Now they want to register quickly so they can get a bit of money on it. These are our time schedule. As you know, being an engineer, there is three main subjects which are encountered. And I would say there are just principles of any discipline in engineering, which is quality, which is time, and which is the cost. So these are like a triangle. It's like you're lucky if this triangle is wspomniane Hermes bring barbatam. So you always have to make sure that this is in line with all tasks that are given to you, which has an impact on the overall project. Typically, for example, it's the designer of the roads. We gave our designers a timeline where the roads need to be finished based on when the construction of the main pipeline will be finished. So what the designer will do is pick the deadline and work backwards. So do all this planning, geological, other studies, environmental, hydrological, you name it, until he reaches the deadline and hands in the project to us. Normally in a normal working way, you always see that the time schedule will always change. So people who plan, and some of them do come from the civil engineering background, which are called planners, they always plan with a buffer zone. What the buffer zone is like, if there is a deadline, for example, third quarters of 2016 for construction next phase, what the buffer has calculated, officially, this is what it tells us, third quarters, but in his head, he has reserved a quarter for planning, because the world is not perfect. We know that there is delays. But all these filters within a company, which is a planner, an engineer, a designer, a project manager, all they do is they match their efforts so that the project can be delivered in time, which means within budget, within the requested quality. Now I'm going to show you the offshore part, which is quite interesting. The onshore is it has many unknowns, but these are foreseen unknowns. The offshore is more challenging because it has unforeseen unknowns during the design phase, and these are details could go up to the salinity of the water. How much salt does the sea hold when you select the pipes that you want to be installing? Is there any active faults in the seabed? How deep will the pipe will go? I don't know how much fish movement. These are even ridiculous things, but they do take them into account, because these are all factors which should be considered when you design a pipeline. The way that we will install the pipe is that we will have a normal steel pipe which has a normal smaller diameter than the onshore part. Why do we do that? Because we know that there is much more pressure when you go down, and our depth, I think, is more than 820 meters deep. This is close to Otranto Bay, if you are familiar with. And we will install a pipe and coat it with a concrete cover, which I believe is 25 millimeters, so it's 2.5 centimeters. These are special concrete, because the pipe will have to sit on its own on the bed. We will not make any clamps onto the pipe so that it stands on its own. And this calculation will be made in a way that it will withhold all the unforeseen risks, such as water currents. Water currents are quite known into, seas, oceans, you name it. We are quite lucky because we don't have many. That's why when we take the designing measures, we take into account even water currents, but to a lower risk than if you say, if the project were to be into in an ocean, which is much more currents. And how do we do it? We go up to Seman, which is close to Fibre. It's a nice beach area. The pipeline, before it goes into the sea, it's stored into a place called landfall. What the landfall? This is a connection between the water and the ground, the onshore with the offshore. And the connection is by a methodology called barge. As you see here, for example, you have steel sheets installed in the ground with, let's say, a corridor of 4 to 5 meters width, where people and machinery can work within the corridor. This goes into the offshore. In our case, it goes into offshore for 400 meters, and then it goes into the sea with a natural gradient, because the sea now, it's got many different gradients normally, the natural gradients. We have to reshape the gradient on a way that the pipe has enough gradient to stimulate the free flow. You have compressors, you have block valves, but engineering, going back to engineering design, engineering and other aspects to engineering is the free flow, because there is no such a good thing than the free flow. Less maintenance, easy to design, easy to install. But because of the geological and the earth condition, we have to have parts where we have to stimulate the flow of gas. Then the pipe goes into the sea with a natural gradient. And to do the natural gradient, as well as installing a steel pipe, we have, this is typical, right? We have dredgers. What dredgers will do is that they will take out the unnecessary seabed to accommodate our pipe. And this is where civil engineering comes into it. How does civil engineering come to it? Well, the landfall needs to have into account shear forces, how much pressure there is from the sea, how much free water there is from the sea when you do the barge, because this will calculate how much time you have to work. In order to have a controlled maintenance, we put a fiber optic next to the pipeline. This fiber optic, the purpose of the fiber optic is to monitor constantly, hour by hour, minute by minute, the behavior of the pipeline. based on natural impacts, because there will be natural impacts to it. So we will design the pipe, and then we will design fiber optic next to it, where we will use our own purposes to measure and raise the alarm if there is anything wrong with it. So then we can use the block valve mechanism to stop the free flow of gas, do the inspection, and then put back gas back into it. This is a typical dredger. So this actually will be into Albania, and as you see, it's like a little city with all provisions into it, including a helicopter pad for health and safety purposes. If there is any injured people, we put them in a helicopter and then we take them out, either in the country hospitals or outside of Albania. Now we've done all these arrangements, and how do we do the installations? So we've made all the preparation, but how do we do the installation for a good pipeline? Well, what we do is we install the winch before the landfall, and then the pipes will be delivered on a big boat on the sea. So all we need to do is now connect the winch with the sheep, put a string in, connect the boat with a string, and then deliver pipes from one end to the other. What this winch does is that he will pull all the pipes into shore until we slowly and gradually we give over the operation to the offshore installations. This is it. This is what it will look like. So this is a permanent, well, it will be a temporary, not a permanent platform. Well, all the installations will be done on the boat, from the delivering of the pipes to the welding and to slowly dropping the pipes onto the seabed. This is fiber optic installation. This is again, if there is more amounts of sand, we'll use dredging. If there is less amount, we will use our own backfill, and most of the times we use gravel, where we shape the bed where the pipeline will fall, and then we'll fill that bed with normal gravel or special gravel, depending on quality of water that we are installing the pipe. This is a typical installation boat. So this is the landfall now. We finished on the onshore part. All the operations from then will start offshore. So there is a big boat which normally can hold more than 2,000 pipes. So everything is like a mini warehouse, but it's all in the sea, where you have quality checks, you have welders, you have testing and commission. Everything is done on the offshore boat, and then it's gradually released onto the seabed. This operation, so the length is 114 kilometers from Albania to Italy, to Brindisi. This normally installation, I would like you guys to guess it. How much time does it take to install this? How much time does it take? No? Less, 2 months. And it's quite good. I thought it was 1 year as well, but it's 2 months maximum.
2 kilograms per day.
Yep. Normally a typical boat like this does even 5 kilometers per day. So it's quite fast. This is the most important and expensive part of the project. This part here. And it's only spent in 2 months.
During the summer?
No, it doesn't matter. It doesn't matter. It could be summer is good to have it, but even summer you can have rain, and these boats actually will hold waves to more than 10 meter high, so they're quite stable.
What about the tubes?
The pipes are delivered. If you see that boat over there, so are delivered from the warehouse, dumped into a different boat, and then brought into our warehouse, where everything is well.
Asking about the pipes affected from these waves. the dropping of the pipes.
Yeah, this is again into engineering. We have taken this into account. This is why we coat them with concrete coating, which can vary. I think it starts on 2.5 centimeters. It can go more as the depth increases. So what this concrete cover will do is will hold the pipe at its stability and minimize movement due to, I don't know, earthquakes, water currents, you name it. And this is the big boats that are coming to do the installation. So this actually is in a cartoon version. This is the real version of it. I think this is it from the project point of view.